Hello, I'm Dr. Ira Goldstein, and we're going to continue our discussion about databases. Today we are going to talk about database normalization. First, a review, defining records and keys. Records are a collection of attributes that have something in common, basically a single theme. Keys are the attributes in a record used to identify that record. Now, database normalization is the process of converting a poorly structured table into two or more well-structured tables. Normalization reduces the redundancy and dependency of data, and in a few minutes we'll talk about what dependency of data really means. Normalization proceeds by dividing larger tables into smaller related tables. Now, the reason we do this is that data integrity problems appear when data are duplicated. A table with data integrity problems will produce incorrect results and inconsistent information. Now, data normalization has 7 normal forms. Forms 1 through 3, Boyce-Codd, 4, 5, and 6. Typically, we stop at the third normal form, and in fact, today's discussion will stop with third normal form. We'll begin with first normal form. We do this by removing repeating attributes. When a relationship contains no repeating attributes, then it is considered to be in first normal form. We'll know this when each attribute in a record has just one value. In other words, a given attribute will not contain multiple instances, such as a phone number, a slash, and a second phone number in a phone number field. Each attribute itself is unique. Lastly, each record will be unique. This is an example of an unnormalized data table, with the employee ID as the primary key. Now, we consider this unnormalized because it doesn't meet the test for first normalized form. Why doesn't this meet the test? Well, if we look, we've got a certification column over here and a certification column over here. In addition, we have a certification date column, or attribute here, and a certification date column over there. So our attributes are not unique. We see that the data could be in either of two columns for certification. So if we wanted to find all the records where somebody took an SPSS course, we would have to search through two columns. Similarly, the dates are in two different columns. So if we needed to find out whose certification was more than 2 years old, we'd have to search separate columns. Taking the data and putting it into first normal form, we see now that we have a single certification column and that we have a single certification date column. We now have each attribute being unique. Each record is unique. And none of the attributes have multiple values. So this is considered in first normal form. Now, to move from first normal form to second normal form, we need to discuss a concept called functional dependency. An item is functionally dependent upon a second item if the second item uniquely determines the value of the first item. For example, employee ID would uniquely identify the employee name. So we can only have one value of employee name for each value of employee ID. In second normal form, every non-primary key is functionally dependent upon the full primary key, whether the key is a simple key or a compound key. To convert a database into second normal form, it must already be in first normal form. We then decompose the relationships into new relations using the attributes that determine other attributes. The determinants become the primary key of the new relation. Let's take a look at how this is done. Here are our records in first normal form. And the problem that we see is that 100 gives us John Smith, but is it John Smith with tax accounting? Or is it John Smith with SPSS? Similarly, does employee ID 120 represent Mary Jones with SPSS? Or does it represent Mary Jones with publisher? This problem can be resolved if we take the employee ID and have it point to just the name, department, department head, and salary. So if the ID just reports to those items, and then we create a compound key where the employee ID combined with the certification. So we take those two and we combine them to create a compound key and have it represent the certification date. So if we do those things, we'll see that we have now two tables. The first table, the employee ID, uniquely identifies the name, the department head, and salary for John Smith. If we want to look up John Smith's certifications, we see that the compound key uniquely identifies that certification date. So the key field in the employee file is just the employee ID. The key field in the employee course file is a combination of the employee ID and the certification. In order to move to third normal form, a database must first be in second normal form, and we need to remove transitive dependencies. A transitive dependency is when a non-key attribute is dependent not only on the primary key, but also on one of the other non-key attributes. In other words, if we change one non-key column, it might cause another non-key column to need to be changed. Now in this example, we have this problem when we look at department and department head. Let's say the department head changes from Emily Gale to another individual. Changing it here does not change it elsewhere. Similarly, if we decide we want to change Pat Frank's department, we will also have to change Conrad Zeus's as a department head to the new department head's name. So the resolution is to break out department and department head into its own table. By doing that, we'll be in third normal form. And here we see that we have a new table, department, with department head and department in it. If we change an employee's department, let's say from marketing to IT, it will automatically associate the appropriate department head with the department. If the department head changes, we would change their name in this one table, the department table, and it would update all of the other records. So in summary, database normalization is the process of converting a poorly structured table into two or more well-structured tables. Normalization reduces the redundancy and dependency of data, and divides larger tables into smaller related tables. First normal form removes repeating attributes. Second normal form ensures functional dependency. And third normal form ensures transitive dependency. As our last item, here's an exercise. This is a non-normalized table. Your task is to put it first into first normal form, then second normal form, and lastly into third normal form. Once you're done, hand in all three versions of the tables, and I'll review them with you. That's all for today. Have a great day.